For Lesson 8's homework on average rate of change, we want to identify how we find the average rate of change over different types of functions, from equations to graphs, tables, and stuff like that. So the first thing we want to make sure of is that when we see average rate of change, the first thing that pops into our head is y2 minus y1 over x2 minus x1. We really have to kind of get that formula into our head. So the first one says use the graph of y equals f of x. Find the average rate of change from x equals -6, we'll call that our x1, to x equals 2, we'll call that our x2. So first we have to find our coordinates. So at -6, 1, 2, 3, 4, 5, 6. So there's our point -6. We get -6 comma -1. So there's our x1, y1. Now we need to find the value at 2. 1, 2. There's our coordinate there. We get 2, -1. There's our x2 and our y2. So now we're going to plug into our fraction, -1 minus 1 over 2 minus -6. We be careful with our signs. -1 minus 1 gives us a -2. 2 minus -6, well, that becomes plus, gives us an 8. And we have an average rate of change of -1/4 or -0.25. Either of those are acceptable. I would rather you keep it as a fraction, but the -0.25, because the decimal is simple, it terminates, we're fine. And number 2, find the average rate of change over the interval 0 to 4. So what that means here basically is that 0 is going to be our x1 and 4 is going to be our x2. So really, we're only focused on a couple of points on our graph. We're focused on the point at 0 and the point at 4. So our first coordinate, 0, 10, that's going to be our x1 and our y1. And then our second point, 4, 6, is going to be our x2 and our y2. So we're going to use our same formula. I'm going to write it a bunch of times to make sure that we really understand. y2 minus y1 over x2 minus x1. So 6 minus 10 over 4 minus 0 gives us -4 over 4, which gives us an average rate of change of -1. For the next one, let g of x equal -x squared minus x plus 6 and n of x be defined by the table. Nancy claims that their average rate of change of n of x is less than the average rate of change of g of x over the interval -1 less than or equal to x less than or equal to 1. So we have to do two separate pieces here. And the first thing we'll do is we'll work on the table first. So if we're going from -1 to +1, those are going to be the 2 points that we're going to focus on. We've got x1 and y1. We've got x2 and y2. So if we plug back in, again, I'll write our formula here in the top corner, y2 minus y1 over x2 minus x1. So if we go 9 minus 5 over 1 minus -1, so 9 minus 5 is 4. Minus minus becomes plus. We get 4 over 2. We have an average rate of change for the table of 2. Now for the equation, we're going to need to use our calculator for this piece. So you're going to want to plug into y equals on your calculator, -x squared minus x plus 6. And then we're going to go to our table. So we'll hit second graph to go to our table. And the part that we're focused on is we just need the points at -1 and 1. So we have -1, 6, and 1, 4. So there's x1, y1, and x2, y2. So if we go to plug into our formula, we have 6 minus, doing it backwards. So we have 4 minus 6 over 1 minus -1. That gives us a -2 over +2, which gives us an average rate of change of -1. Now what we want to do is we want to make sure we answer the question. Now it does say justify, so you don't have to write an explanation. Your work can suffice here, but you do have to actually determine if Nancy is correct. So let's reread the question. Nancy claims that the average rate of change of n of x, that's our table, is less than the average rate of change of g of x, which is our graph. Well, our table had an average rate of change of 2, and the equation had an average rate of change of -1. So therefore, Nancy is incorrect. Okay, because our table definitely has an average rate of change that is greater than the average rate of change of our table. Excuse me, of our equation.